testing, hello, testing.
Hey, good morning, everyone. Welcome back for day 3 of our marathon colloquium. I will introduce our first speaker of today, Mr. Lo Lei Ming. This is his thesis, his PhD update. So, Mr. Lo, you have 15 minutes to complete your presentation.
A very good morning to everyone. I will just do a very brief introduction to myself as well to my project. So I'm an AS master student been doing here for MSD. I joined here 2014, I believe. So I joined under the same project being sponsored by Hatta Lega doing the wastewater treatment. Mainly to remove the ammonia. For 2 years, I've been invested into it and deep inside the project. And so now, 2016, I proceeded to my PhD project under the same sponsor, doing the same project, but larger scale. As you can see from my title, is doing up to pilot scale and the industry scale. So I will just, this is a progress update of mine. So it will briefly go through everything happening in 2016 and 2017 and up to now. So from the flowchart here, in the very early beginning of my project, my PhD project, I mainly transfer all my findings from my master's to my PhD, and then I proceed to a larger scale by using basically biological treatment to the wastewaters. And then over the year, you can see I have invested into different kind of approach to try to improve the whole treatment. So mainly I have deal with the different kind of carbon source like molasses and POME. POME will be standing for palm oil meal effluents, which have been found to be have a very high carbon content in order to help the bacteria to treat the waters and mainly to remove the ammonia. In 2017, I actually tried different kind of approach in order to further push the result further down. So my main objective in this project is actually to remove ammonia in the wastewater effluent to achieve the basic Malaysia Department of Environment standard. They have two standards, standard A and standard B. For standard B, they have a limitation of 20 milligram per liters of ammonia in the waters. And for the standard A, will be 10 milligram per liter of ammonia in the water. And my objective in SEC is to achieve standard A, which is below 10 milligram per liter of ammonia. And my personal goal actually is try to achieve below 5. So in order to achieve that, to be safe side, I try different kind of approach. Look at here at the first fixed point, I actually try geolite. I will actually elaborate more on different approach later. So this is just a very brief go through. It's a very brief flow chart. Secondly, I try chitosan. Actually, is a very one of the outrising product being used for slimming down for ladies, which if believe can be able to absorb most of the oil particle in the bodies. But I actually use it for the coating of the bacteria in order to protect them. And lastly, I even try different kind of chitosan in order to achieve even higher result. So next is I introduced bioaugmentation inside my project. This is one of the process where you need to adapt the bacteria to the system before you actually ask them to work for you. So at the very last two is the very big jump off is Actually, from pre-pilot scale, which means that from the left scale, which is about 10 liter of water I drink, I actually improve it to 50 liter. And after that, for the industry scale, I actually aim for 1,000 liter of water waters. So here's the kind of the details of starting of different kind of approach I actually try. So for the geolite pre-treatment, actually I invested into because there's a lot of papers being studied that geolite is very good absorbent for the ammonia. So I introduced geolite into my project and trying to see if there's any optimization I can further improve. And then the Kaido-san bit, you can see I attached some of the picture here. This is all the bit that I make personally in the lab. This is not purchased, handmade from the size of like a BB gun bullet to up to like a thumb size. This is this big. It consists of the bacteria that I invested. They are actually just like making a jelly. The bacteria is normally in a liquid culture, so you need to solidify it, and so that they are more sustainable and they have a higher survival rate inside the wastewater. So this is the geolite. This is how it looks like. The geolite is actually a kind of stone that have a very high absorbent in terms of the water as well as the filter for the ammonia. For my result here, actually, when I introduced geolite into my wastewaters, they achieve a very different. They achieve a better result than without using a geolite. You can see I have circled it. It's compared between around 20 milligram per liter to 10 milligram per liter. It's literally around standard B and standard A range. Next is the Kaido-san that I mentioned. This product is in the market now. Mainly people have been doing it for a slimming project, which is for the human consumption. But I have been investing it into the wastewater treatment, actually for the coating, because it's a protected area for the bacteria. You try to protect the bacteria inside the wastewater because there's all kind of harmful chemicals, pH, temperatures. Everything can affect the performance. Next is the bioaugmentation that I mentioned just now. This is a very brief chart. Actually, just explain the bioaugmentation just like that. Because when you introduce your bacteria inside the waters, inside the water there is not only your bacteria inside. There is all kind of indigenous bacteria or all kind of fungus and everything is inside. So the bioaugmentation, the purpose is try to make your bacteria dominant inside the whole system. So this is how it rolls like. So the desired microorganism maybe is the B. So what you do inside during this bioaugmentation period is that you try to make it dominant over the whole system so that it can be the main worker inside the treatment. So the result here actually, just by this, I actually push it down to 3.66 milligram per liter, which is actually achieving my personal goals, which is below 5 milligram per liter. And while at the same time achieving the Malaysia Department of Environment standard A 10 milligram per liter. So the reduction rate can achieve up to nearly 90% of the removals. So from here is about initial 33 milligram per liter for ammonia in the waters. I managed to remove down to 5. So the last stage of my project here is actually try to upscale it out to industry pilot scale, where I'm no longer working in the MSD lab. I need to move around, go to the industry, the actual industry. They will help me to set out a tank like this. This is a tank of 1 meter cube, which is equal to 1,000 liters. And actually, this is a pilot scale treatment, so I just adopt whatever finding I have found in the lab, and I just applied it to the plant. So the actual goal for the plant and my sponsor is actually try to treat your actual SPL tank, which is I mentioned down there is actually the sequential batch tank. That tank is about 2-story high. So I checked it just now. The total volume is about 600,000 liters. So that is the amount of per cycle of liter they need to treat every day. But that is only one cycle. For every day, they have 4 cycles. So that's 600,000. You need to times 4. That is the amount of water that particular industry need to deal with every single day, non-stop 24/7. So this is a very quick line chart of my achievement here. So for the pilot scale, the 1,000 liter, from around 14-15 milligram per liter, I can straight away push it down. Actually, achieving the standard, which is DOE standard A, required by the government by just within 2 hours. but I further push it down for 6 hours because their system is 6 hours. So I push it for 6 hours. The final achievement is around 5, it's below 5. So this is actually basically, this is the main major progress out there of my project today. So thank you for your time. So if there is any Q&A, so I open up for the questions.
Yes. Is there any comments?
Anything not understand maybe? Because I found it could be very difficult to most of the people here because most of them is not science-based. Is yeah, so anything you are curious, you can ask.
Okay, so Law, what will be your possible next step after you have completed this research?
This research is mainly to aim for helping most of the other industry in the line. So those industry that having the ammonia problem is not just particularly one industry. My sponsor is a glove manufacturer industry. So for the raw material, they store their latex in the ammonia. So they have this main problem. The other industry may be like rubber industry, agricultures, aquacultures, all of this kind of industry, even palm oil mill, they all have this problem, which they have ammonia contaminant in their waters. So I will wish that this finding will eventually help most of this kind of industry, eventually help them to solve this problem in their downstream treatment.
Okay, is there any other more comments from the floor? Okay, just to share, Mr. Law has filed a patent for his previous project, his master project. So for this PhD project also, he is currently filing another patent for this current finding. So this is, I think, what is a very good achievement for a postgraduate student, okay, to be able to get a patent out of his work. Okay, thank you, Mr. Law.
Thank you.
Okay, now, so we are awaiting our speaker of the day to come. He should be arriving, I think, very soon. So in the meantime, maybe you can have some tea or coffee as a break. Feel free to have some tea or coffee as a break, but please be present in the hall. So because the speaker may arrive anytime soon.